So that's the drawing portion of it. What about checking for the force of an object? So calculating the forces, I'm going to make this a separate function. All right, so I'm going to create this function called calculate force. I'm going to call it here, name it here. And his job is to go through and calculate the forces of every object on each other. This is using the gravitational equations. So we're going to consider the mass and the radius in order to figure out what the force on each thing is going to be. And that's going to inform our acceleration. Once again, go through all my objects. Okay. So to begin with, I'm going to set all my accelerations to be 0. So basically clear out accelerations, and then I'm going to recalculate these all. So to begin with, set them all to 0. Now I need to actually go through all of the other objects and check to see what their force on this object is. So if I look at the 0 object, for example, I need to go through and figure out the force from the 1 object, the 2 object, the 3 object, and basically add those all up. So what I'm going to do is create another loop that basically walks through the array again and use a different variable, so b in this case. And consider the force on A based on object B. So to begin with, I better make sure that I don't consider myself, because the force of myself might lead to a division by 0, because the radius would be 0. And then I want to watch out, once again, for any objects that I've removed. And the way I'm checking for that is making sure the mass is not 0, which also might lead to a division by 0 problem, which is why I'm doing it this way. All right, so if I am not the same object and I don't have a mass of 0, now I need to consider what is going to be the amount of force. In calculating the triangles for our force, we are basically trying to figure out the distance apart from 2 different masses. So if you imagine one mass is here at the end of these arrows, one is down here at the beginning. So we can use the Pythagorean theorem to figure that out, the x and y distance. X squared plus y squared is equal to our distance squared. And then we use that calculation in our force equation. So gravity times the mass of the first one times the mass of the second one divided by the radius squared, radius being the distance between the two. Now, once we have that force, we need to basically figure out the x component and y component of the force. Well, fortunately, because the force is in the same direction as the distance, we actually have 2 similar triangles here. These angles are the same. So that means that we can basically take the proportion of the distance, the position, and the force compared to the force of the x value and the force of the x distance. So let me add a couple of variables up here above setup to help make this easier. So I'm going to create a floating point number, which is going to be the difference in x positions, floating point number for the difference in y positions. I'm going to use another float to consider the distance between them when I actually need to make that calculation. And why not? Let's add in a float for the gravitational constant, though for now I'm just going to leave this at 1. We can play with this number and see what it actually does later on. All right, what else do we need? We're going to need to figure out the calculation of the acceleration as well. Well, let's start with this. So to begin with, let's figure out the actual difference in the x coordinates. So we're just going to take whatever x coordinate b has and subtract the x coordinate of a. Same thing with the y's. The distance between these, which is our force distance, is going to be the Pythagorean theorem. So a squared plus b squared equals c squared. The hypotenuse is going to be the square root of this squared plus this squared. So the square root of the square of diff x plus the square of diff y. All right, so what is our force? Let's add force up here. So our force equation is the gravitational constant times the mass of the first thing times the mass of the second thing divided by the square of the distance, which is usually considered the radius. In our case, our distance is this hypotenuse calculation we just made. All right, well, that's very exciting. Now we have our force. So the next thing we need to do is figure out the x and y components of the force. So let's do x force. Normally I could do this all in one calculation, but I wanted to break it apart into pieces to show you what the different parts would be. So our x force is going to be basically a proportion. You might also consider this, if you knew the angle, to consider the arc sine. Well, arc cosine for the x. For now, we're just going to use the proportions and get the same calculation. This will be the amount of force in the x position. We need a similar calculation for the y. And then we're finally to the point where we can add that to our acceleration. Because if we divide by the mass, then we have our acceleration, because force equals mass times acceleration. So we're going to take our current value, add whatever we had before, because remember we're doing this for every single mass of B. So we're going to basically have a total of these things and add on the x force divided by the mass of A. Same thing with the y. And then finally, once we have figured out all our accelerations, hooray, we now need to update our velocities based on that. If you're going into stepwise simulation, all you have to do is keep adding to the velocities all of the acceleration. And there we go.